the importance about determining the structure there is that the scientists are doing a lot of research and in different areas and every year. So roughly about 500,000 compounds, new compounds, are discovered or synthesized. And some are naturally occurring, some are man-made. Okay? And for all of these 500,000 new compounds there, the first thing we need to know about these new compounds is what is their formula. We have to know what's in there and how much is in there. So determining the structure, determining the formula is very important there. So when we try to determine whether a particular formula is empirical or molecular, well, you have to look at whether you have the simplest whole number ratio. Here's an example. If you have ethane, okay, and ethane, the molecular formula is carbon 2, hydrogen 6. Okay. For two carbons there, when they connect to one another, each one can also take 3 hydrogens with them. So this is the molecular formula representing the actual number of atoms in this compound there, in this molecule. Okay. Now the empirical formula though is going to be CH3. Okay. So molecular formula is carbon 2, hydrogen 6. The simplest whole number ratio would be divide everything by 2. You end up with C1, carbon 1, hydrogen 3. So this would be the empirical formula. So first of all, when we try to analyze and when we try to determine the structures there, we need to know when we come up with the formula there, the simplest whole number ratio may not be the molecular formula. It could be, but it may not be. Okay. Now the thing here is that we also need to know the molar mass of the compound. If we know the molar mass, we know the formula for the empirical formula for the compound there, we can determine what this number is going to be. Okay. The mass, the molar mass of the compound determined from, say, mass spectrometer, divided by the formula weight of the empirical formula, will give you this small number, that's K, the whole number there. So from there, if you know the empirical formula, if you know the molar mass, you can determine what the molecular formula is. And we'll give you some examples there. So the empirical formula multiplied by that whole number will give you the molecular formula. And here's some examples there. Okay, so for compounds here, we want you to be able to recognize a particular formula, whether they are molecular or empirical. Okay, so hydrogen peroxide, hexane, and carbon disulfide. Okay, so the molecular formula would be H2O2 for hydrogen peroxide. Empirical formula would be HO. Okay, hexane, hex means 6, so carbon 6, hydrogen 14. The empirical formula would be carbon 3, hydrogen 7, the simplest whole number ratio. Okay, carbon disulfide, CS2. The empirical formula would be the same, just 1 to 2. That's already the simplest whole number ratio. Okay, so this is something that we want you to be able to recognize first. Now, examples for calculating the empirical formula for compound there. Given a sample that is 79.89% of carbon, 20.11% of hydrogen, we ask you to find the empirical formula. Now, when you see a question like this, which is something that you will encounter in chapter 3 when you do homework assignments there. Now, when you see something like this, the first thing that we want you to do here is that if the mass of each element is given to you as a percentage number, let's assume we have 100 grams of the sample. Now, if you have 100 grams of the sample, the percentage number, you translate the percentage number into gram. So if you assume that you have 100 grams of this compound, which we don't know what it is yet. Okay. If you assume you have 100 grams of the sample there, then 79.89% means that 79.890 grams of the compound out of this 100 grams is carbon. 20.110 grams will be hydrogen. Okay. So assuming you have 100 grams of sample there, you get the mass of the carbon. If you have the mass of the carbon and hydrogen, you can convert them into moles. Now, how do you do that conversion? Where do you find the conversion factor? There's a table somewhere starting with a P. Periodic table. We have the ton of mass in there. So if you know 79 grams, if you know you have 79.89 gram of the carbon there, each mole weighs 12 grams. you get to conversion factor. All you need to do is to convert that 79 gram into moles and 20 gram into moles, then take the ratio of those two numbers. That gives you the molar ratio. The whole idea of coming up with the empirical formula is to determine the molar ratio. So if you make the assumption that you have 100 gram sample there, you convert the percentage number into grams, and you can use the periodic table and find the conversion factor. You can convert these numbers into moles. Once you get it into moles there, you can determine the simplest whole number ratio. Okay, so this is what we do for determining the number of moles. Assuming you have 100 gram of the sample there, this many gram will be carbon, this many gram will be hydrogen. Conversion factor, this information comes from the periodic table. Okay, doing the calculation now we know, but every 100 gram of the sample, we have 6.65 mole of carbon, we have 19.952 mole of hydrogen. Now, if you divide the bigger number by the smaller number, you get the molar ratio between hydrogen and carbon. Okay, so in this case, and if you divide 6.65 by 6.65, you get 1. Okay, if you divide 19.9 by 6.65, you get 2.9997. Well, we can round it up to 3. So this tells you the molar ratio between hydrogen and carbon is 3 to 1. The empirical formula would be CH3. Okay, so that's how we determine the empirical formula based on the percentage there. And of course, the most fundamental question in this question is, how do you come up with the percentage there in the first place? Well, there are different ways to do that. So this is, if we give you the elemental analysis result, percentage percent composition of the elements in the compound there, and this is how we determine the empirical formula. And once we determine the empirical formula, we also need to make sure, in order to figure out what is the molecular formula. Now, there's one more piece of information you can get. That one more piece of information is going to be, what is the molar mass of the compound? Now, to determine the molar mass, you can use different instruments there. You can even use different methods to determine the molar mass. So, assuming we have a mass spectrometer, very expensive equipment instrument that in the laboratory there, and assuming you have a molar mass spectrometer there, and you subtract the sample through the instrument there, you can get the molar mass. Now, we find the molar mass, the formula, empirical formula mass, we have CH3 here. Every mole of CH3, you have 1 mole of carbon, 3 moles of hydrogen. 1 mole of carbon is 12 grams, 3 moles of hydrogen is 3 grams. So, dividing the molar mass by the formula, 15 grams per mole, we can determine the ratio between the empirical formula and the molecular formula. So that's going to be this number. Okay. Once we have this small number there, we simply multiply everything in the empirical formula by that small number. We will come up with the molecular formula there. So this is one step further about the previous question there. Okay. If we have given the mass of the molar mass of the compound being 30 grams per mole, and the formula that we determined, the empirical formula is CH3. CH3 is somewhere around 15. Carbon 12, hydrogen 1, 3 hydrogens in there. Now, if the molar mass of the compound is determined to be 30.06 grams per mole through mass spectrometer, through other methods there, then 30 divided by 15 will give you 2. Then the molecular formula for this compound, we have CH3 as our empirical.